Hello everyone, this is Shoaib Mohammed Khan. I'm going to today start you and show you the milestone one and how far we have achieved in this project. So far we have been using about 11 patterns which are singleton factory object pool, priority queue proxy command and iterator template pattern and composite null object and also adapter pattern. So let me first start you by starting the application. As you can see here, the application has been running as per the requirement of the milestone one, in which you have to turn around from about some amount of pixels and again turn around at some amount of pixels. And most of the animation and the movement has been happening with the help of the timer event manager. And also I am able to uh, hide and show the sprite boxes by just using the buttons U and B. And let me show you the patterns. Yes. So as you can see here, I have been using sprite singleton pattern in the sprite batch manager, or I can even see the sprite box and the sprite batch manager. And to create the instance, we have been using a private constructor and a singleton create function to create it. And here is the instance being created. And in the game file, you can see all the singleton classes, and they are being instantiated at once and deleted at once. So, and whenever you try to access them, there will only be one instance which will be accessing them. So this is mostly used in all of the managers. Other than that, we have been using factory pattern to create all the birds and the aliens. As you can see here, I have been using a file called bird factory and alien factory. Alien factory is right here. We are using it to find the sprite batch and find the sprite box batch. So we have created two different types of batches in order to disable the boxes. And so far we after that we select the object to create based on the parameters passed, and then we attach them to the sprite batches and create the sprite and collision sprite. So the collision sprite is basically the box. This sprite batch is the main game sprite. Other than that, we have been using object pools. So basically, any manager you can see, like in image manager, let us take that. So in image manager, we have been using the object pooling in a way that when you create the object, you are also creating a reserve and a pool to add all the images. Just like here, when you create this manager, you have a reserve number and a reserve goal. So this is a manager which has a list of nodes which can be either in reserve or in active. So that is object pooling. And other than that, we have used priority queues. Basically, we have used them in timer event manager. So in the timer event manager, you can see that um, the basically when basically in the it's used in the priority of the events, right? When you insert the event, it should be at the correct position. So while we are adding the event, we get the instance, then in the base add we iterate and add it at the right place. So that is how we are using PQ. And proxies have been used in the game, Sprite Game Proxy and Sprite Game Proxy Manager. So this is basically a lightweight object which is pointing to the main sprite, which also owns the actual file of the image and the sprite and which has the image. So basically they require a lot of memory, but we do not want to instantiate so many images and just the three or four or five sprites and then use it to draw the rest of them using the proxy pattern, so that it is more efficient way to draw things. And then after that, we have used the command pattern. The command pattern has been used here in the timer event manager, and these are the commands. Like I have made this move command in order to move the sprites, and like basically here I'm uh, moving the sprite. So how I'm doing is like checking the limit and then calling the basically calling the move function. So this move function is inside the game object, which is an alien grid, but it only executes when the delta time has occurred, basically. After that, we have used iterators. So we have used iterator in a lot of places. As for example, we can say that we have used in Sprite Batch Manager. So when you go to Sprite Batch Manager, there are a lot of like you can see, I'm using the iterator here. This iterator is being used to get this is basically to add with priority. Even for that, we are using iterator, and even in other cases, here you can see us using the iterator. So basically, when you are drawing, also you want to iterate over the nodes and then call the sprite node manager's draw function. So that is where we are using the iterator pattern. And iterator pattern is like a standardized pattern which has like first, done, and next, so that it can iterate over any kind of data structure. So after that, we are using a template pattern in Sprite Manager. So in the Sprite Game Manager, right, we are basically how we are implementing this is when we are calling the derived class, right? So when you call the derived class, derived class is create function. So it goes and creates the derived object and returns it. So this is overriding the node base basically. So instead of creating a node, it is creating a sprite game. That is how we are using template pattern. And then composite pattern, we are using it in this basically uh, class. So these composite component and leaf are like a pattern in which you can make an object also in the form of a tree. So there are trees, and in the tree basically there is leaf nodes and there are non-leaf nodes. So non-leaf nodes here are called composite nodes. So composite nodes and leaf nodes are all derived from a single class called component, which is in turn derived from d-link. As you can see here, I'll show it to you in the class diagram. So here is the class diagram of composite. So you can see the game object being extended from component and the leaf, and the composite is being also extended from the component. After that, you can create the grids and columns and basically normal objects and also the game HTML object. Coming to that, we are also using the null pattern with these as in when we are trying to create like a proxy which is null. So basically these objects do nothing. So when you call the render function, it is supposed to render nothing. So this is one of the things that professor give the analogy of in the factory you are using a box to get rid of spraying over some kind of material which is not supposed to be free spread. So this is using the similar method. So in order when the render is called on the sprite games which are not pointing to any sprites, real sprites, so we instantiate them with the null object, and then when the render function is called, we just do nothing. So that is the null object, and then the adapter pattern also we have implemented it in the texture class. So basically how we have implemented is like there's an texture, uh, and the texture is basically an Azure texture. So, but when we want to access it, we access it through our classes. like we want to get the name, but we use the this function. We want to texture, so we call the texture set, but inside our set function, and we want to instantiate and create a new texture. So we call the new, but not directly, but using our class. So the other things the class is doing is the assert and then setting the name and other things. So this is the adapter pattern. And other than that, we have named every new, as you can see, if it is a long-term new and short-term new. And we have also used object pooling. So object pooling is basically the manager reserve that we created in order to add and remove the objects from active and reserve list. So that the active list, so that we don't create a new object now every now and then, and our memory is in a very organized manner and efficient also. So as you can see in the manager base, this is basically how the manager reserves implemented the object pooling, uh, and it is also the base class for all the managers. And I have also shown you the working of all the features in the application, and the grid and everything has been drawn according to the requirements. And we can also discuss all the diagrams, just like for the timer event, and which is basically using our which pattern is it using? Yeah, it is using the priority queue pattern. So in the S-Link, we are inserting it into a chronological kind of order. So that is where the uh, priority queue is being used, and singleton is almost used in every manager. And then I can show you all the patterns in the diagrams as well, basically like in the proxy. So this is the proxy pattern, and herein we are pointing it to a real game sprite. So that is the proxy pattern, and there's a proxy manager and the normal manager, and this one has all the uh, variables as you can see here, which are like color and rectangle and image and everything. So I think that is it for it. Thank you very much for watching. Thank you.